Hi guys, welcome to the Pepcoding. In this video, we are going to solve ways to make a fair array. So let's see this question. So we have given an array and we have to choose only one index and we can remove the element of that index. After removing that element from the array, if we add if we sum all the odd indexed values and the even indexes values, if both are equal, if the sum of odd indexes value and the even indexes value are equal, this means that array is a fair array, and we need to return the number of indices that we could choose such that after removal nums is fair. So how many ways to make our array fair, and we have only exactly one element we can remove. So let's say we have 2 1 4 6. This is a array having index 0 1 2 and 3. Now if we remove this from the array, our element will be 1 4 6. Let's take another. It will give us, let's take 2 1 6 0 1 2 3. Now here, if we remove 2, we will get 1 6 4. Let's write the odd indexes sum and even indexes sum here. Now if we remove this element, the indexes will be decreased by 1 after this element. So here this will be 0 1 2. Now odd sum is this 6. Even sum is at 0th and 4th index. So the sum of the elements are 5. Here we can see odd sum and even sum are not equal. So this is not a fair array. Now if we remove 1, we will have 2 6 and 4. Here the odd indexes sum is 6, and even indexes sum is 0th index and second index. So if we sum these two elements, it will give 6. Here we can see odd sum and the even sum are equal. So this means this is a fair array. If we remove 1, we can make a fair array. So this is a count, that is, if we remove 1, we can get the fair array. So this is the count that there is one way. Now if we remove 6, this will be 2 1 and 4. Odd sum is 1, even sum is 6. They are not equal. Now if we remove 4, we will have 2 1 6. Odd sum is 1, even sum is 8. This is also not a fair array. So our answer will be 1. This means there is only one way to make fair array, if we remove 1. Now for doing this question, we can solve it in O of n square easily. How? We just need to use two nested for loops. Here two nested for loop will be used for all the elements we have, like 2 1 4 6, and we will calculate each time for the odd sum and the even sum after removing this or removing this or removing this. And if the odd sum equal to the even sum, we will count the answer plus plus, but this will take O of n square. Can we do it in O of n? Now let's see, we will solve this in O of n time. So let's say we have element 4 5 8 6 3 1. So let's say this is the array we have. Now this is at index 0 1 2 3 and 4 and 5. These are the indexes. If we want to remove any ith index from this array, what if we have already the sum of all the values in prefix sum. Let's check all the sum in an array. Let's say even sum, prefix even sum for the even index system. Now even indexes are 0 to 4. Now till 0th index the even sum is 4. 1st index sum is 4. 2nd index sum is 4 plus 8, that is 12. This is even sum, prefix even sum. Now we are at 3. This will be not include, so this will be 12. Now here we are at 4. This is a even index. So we will add this 3 with 12. This will be 15. And at the last, this is odd index, so this will be 15. So this is the even sum of this array. Odd index is sum. Let's save this also. For odd indexes, 0 is not odd index, so it will be 0. Now 1 is odd index, so start from sum 5. 2 is even, so this will not add in the odd sum prefix, so this will be 5. Now 3 is odd, the element is 6. We will add 5 plus 6, that is 11. Now index is even, so this will be 11. Now index is 5, that is odd, so we will add 11 plus 1, that is 12. So we have even sum and the odd sum. We will use this sum to calculate the sum, the odd sum and the even sum after removing any element at ith position in the array. Let's see how. Now let's say we have to remove 40. So the indexes will be 0, 1, 2, 3 and 4. This will be the index of the array and the element will start from 5. But the even sum and the odd indexes sum will be changed. Here the odd sum was before 4, the odd sum was this 12, but now the odd sum will be changed by even sum, because if we remove any element, the odd index will be even index and the even index will be odd index. So the sum will be changed from this position, I plus 1. Here the odd indexes sum will be the even indexes sum and the even indexes sum will be odd indexes sum. How? Let's see. So from here we can see odd sum will be for these indexes after removing 4. So the odd sum is 8 plus 3, that is 11. Even sum 5 plus 6 plus 1, that is 5 plus 6 plus 1, that is 12. Here the odd sum and the even sum are not equal, so this will not be counted in answer. This is not a fair array. But how will we get this 11 and 12? If we want this again, we need to iterate. We have prefix sum of even sum and the odd sum of the num array. So we will use this to find these odd sum and even sum. So till the I minus 1, the sum will be same. So here till here the sum will be same, but here there is no element. Let's remove 5 to see the example again. It will make more clear to understand. Let's say 4 is there, 5 is there, and here we are removing 5. So this will be at the 0th index. Now the sum will be odd sum for this array. Odd sum is this 1 and 3, that is 11. Even sum will be 4 plus 6 plus 1, that is also 11. So here both sum are equal. Both sum are equal. So this will be count as answer plus plus. There is a one way to make a fair array. This is a fair array if we remove 5. But how will we get this 11 and 11 for odd sum and even? So we are removing ith index, that is 1. Till the I minus 1. Till the I minus 1. The odd sum and the even sum will be same. Here if we see the odd sum prefix of this, it will be 0 of this I minus 1, and even sum will be 4. After that this is odd. So here will be 8. This is 0, 1, 2, 3 and 4. This is even sum. This is odd sum after removing 5. So let's calculate this. 4 and here this will be 4, then 10, then 10, then 11, and for odd sum 8, then 8, then 11, and then 11. So this is the even sum or odd sum. But we can get this value by using this prefix, sum of odd indexes sum and the even indexes sum of the array. So here if we see, we have removed 5. After this, all the even indexes are the odd indexes. This was even index, but now it is odd indexes. So the sum of even indexes from here will be equal to the sum of odd indexes now. So if you want the even sum from this index, for 1, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 and 5. For this, if we see the total sum from I plus 1 to I plus 1 to n is 15 here, minus that element till that element sum, till that the odd sum. We are checking for the odd sum. Odd sum after I plus 1, it will be even sum, that is 15 minus till that element, that is ith index, 15 minus 4. 15 minus 4 here, plus what? We need this is the total sum from I plus 1 till n, and we need from 0 to I minus 1 also. So from that we can get it from here. This is 0. So this is equal to 11. Here we have subtracted the values of the last, that is even sum at n minus 1, minus even sum at I. This will give us the prefix odd sum at I. So it is giving the value, that is 11. Here we can see the total sum is 11. Now for the even sum till I minus 1, that is 4. This is 4. The total sum will be odd sum minus the index at I of odd sum. 12 minus 5, that is 7. This is the sum from I plus 1 till n, and we have already 0 plus 0 to I minus 1 value, which is 4. We have already even sum indexes, that is 4 till I minus 1. So this is 4 and this is 7. 7 plus 4 is equal to 11. Here we can get the even sum. Now let's remove another. Let's remove another value. Let's remove 8. Let's remove 8 and see the result. This is 4, this is 8. And we are removing 8. This is 0, this is 1. Now odd sum and even sum of this array. Odd sum is 5 plus 3, that is 8. And even sum is 4 plus 6, 10, and plus 1, that is 11. These are not equal, but we will get these values by using this prefix sum. So for the odd sum, new odd sum will be till the odd sum at I plus the even sum I plus 1. This is till I minus 1. This is I minus 1. Odd sum till I minus 1 plus this is the sum from 0 to I minus 1. Now we need I plus 1 to n prefix sum, which is we will get from even sum at n minus 1 minus even sum at I. This will be the new odd sum. So let's calculate this. So here I is 2. We are removing it. I is 2. So for odd sum till I minus 1, that is 5. This is odd sum 5 plus even sum n minus 1, that is 15, minus even sum at I, that is 12. This will give 5 plus 3, that is 8. This is new odd sum. New even sum will be even sum till I minus 1 plus this is from 0 to I minus 1. We have the even sum till 0 to I minus 1. We are removing I. So after I plus 1, the values will be changed. So here this will be odd sum of n minus 1 minus odd sum at I. So let's calculate this. At I minus 1, the even sum is 4 plus odd sum at n minus 1, that is 12, minus odd sum at I, that is 5. This will be 4 plus 7, that is 11. So this is new odd sum, this is new even sum, this is new odd sum of the array if we remove 8. And here we can see the odd sum is 8 and even sum is 11 of the array if we remove 8. And we have get these values by this formula. So we will use this. First step is to find the prefix sums of odd indexes sum and even indexes sum. Then we will iterate for finding all the elements, removing one by one the ith element, and we will use this formula for finding a new odd sum and new even sum. If both are equal, we will increase answer count by 1 and we will return the answer at the end. So this is the explanation. Let's code this. So first we need the length of the array to make odd sum array and even sum array. For that, int n is equal to num.length. This will give us the length of the nums array. Now we need two arrays, one for odd indices sum having size n, another one is for even indexes size n. Now we need two variables to calculate odd sum and the even sum of the odd indexes and even indexes in the nums array. Now here we will find the prefix sum of odd and even indices elements. Now here we will iterate from 0 till n minus 1, and inside this we will check when I is odd, when I is even. I am odd, 2 is equal to 0, this means I is even. In even we will update even sum by adding numset I, else the index will be odd. So here we will update odd sum plus equal to numset I, and each time we will update odd I is equal to odd sum and even at I is equal to even sum. This will update the odd indices and even indices sum of the elements. Now we need a count for answer for checking number of elements after removing ith element. How is the array fair or not? For that we need again to iterate from 0 till n minus 1. Now here we will check new even sum. So the new total even sum will be till the I minus 1 we have the sum in even indices sum, that is even at I minus 1 till I minus 1 we have till I minus 1 already. We need to find from I plus 1 till n. For that we have in odd n minus 1 minus odd at I. This will be the new even sum. Now for new odd sum, till I minus 1 we have the sum. After I, that is I plus 1 till n, we have in even sum at n minus 1 minus even at I. Now we need to check if NES is equal to NOS. We will update the answer by 1 and at the end we will return the answer. But here there is a case. Here we are starting I from 0. When I is equal to 0, this will check for even at I minus 1, that is even at minus 1 index. But there is no minus 1 index in the array. So this will give us error. So for that I am going to use ternary operator. When I is equal to 0, we will add 0 in the new even sum. Else we will add I minus 1. Same for the odd. I is equal to 0, then add 0. Else odd at I minus 1. So this will save us to not getting array. This is the ternary operator. When I is equal to 0, this will give 0 to add new even sum, and if it is not, it will add the prefix even sum till I minus 1 of the even index system. So let's try to run this. Let's try to submit this. So all the test cases are passed, and this is the simple code where we have done this in O of n time, where we have iterated from 0 to n minus 1 for finding the prefix sum, and after that we have removed all the elements from 0 till n minus 1. One by one we are checking the new even sum and the new odd sum, and if these are equal we are increasing the value by 1 of the answer. So hope you understand the concept. We'll see you in the next video. Thank you.